Good morning, everyone. Welcome back to the class. So let me just have the share screen done. Share screen enabled. So I hope now I can start teaching. Okay. Yes. Okay. So last time we have discussed heap sort. I hope you have done the programming of that. And along with heap sort, you have also understood the basic use of a new data structure, max heap. Of course, similarly, we can have a min heap also. So it's a useful data structure. Of course, along with heap sort, it can be used in many other situations. And we are going to see some situations where this will be useful in many other scenarios along with sort. For example, let's talk to the operating system level. Now, in operating system, many processes are active at a time. What is a process? Effectively, any program in execution, we call that as a process, but in OS, you will study in detail. So if I'm, let's say, I'm clicking on Firefox, I am also clicking on VLC media player. I am also clicking on some printing activity. I am also working with the DevCpp. So all these processes are actively available and they are available for execution. One CPU available if at a time will mean one process to be executed on a CPU. To be executed. Now, the question is, which process should be executed? So there has to be different algorithms for that. So that is called as a process scheduling. And when I say process scheduling, there are different CPU or process scheduling algorithms available called as a CPU scheduling or process scheduling. One of them is called as a priority schedule. Priority scheduling means the job with the or the process with the highest priority should be executed first. Process with highest priority. So process with highest priority to be executed first. And that will mean I should find out which process has got highest priority. Now, there will be lots of jobs, lots of processes which will keep on coming time to time. Each will have a different priority. Operating system by default assigns some priority. And we say that if there is some process with a higher priority, that should be executed before a process with the other priorities. So in that case, I need to find job with the highest priority. Say, if I have out of n processes, I'll say, let me correct this. Out of n processes, find process with highest priority. Now, which one is that? I need to find out that. Yes, one solution can be keep sorted list. And then you need keep sorted, I'll say descending sorted. And then from the top, you can take the first step. First process will be obviously highest priority. Well, can work, but keeping it sorted always has an issue that first thing you have to do the sorting. The n log n time will be spent on this minimum. Secondly, what about a new job to be added? So new job added, new process comes with certain new priority that is to be inserted. Insertion will also take time, order of n. So all that will take time. Instead of going for all this, I can use a concept of, or normally concept of a new data structure which is known as a priority queue, is used. What is that? We normally call it as a PQ. So as the word suggests, it is a kind of a queue based on priority. But internally, it is nothing but it's a max heap. So now you will connect why we are talking it immediately after heap sort. So max heap is going to be a data structure which will be used as a PQ. So PQ is nothing but it's a max heap with 4 operations allowed, along with whatever you can now internally max heap will be using those its operations, but over priority queue we are mainly permitted to apply 4 operations. First operation, find max priority or find max, normally we say. Second operation we say extract max. Third operation, I say insert. And fourth operation, I will say is the increase. We will go one by one. First, both appear to be simple, find max versus extract max, but they are different in the sense that extract max will mean extract the job or process with highest priority. Extract with highest priority. Extract will mean it will be removed from the list of the processes. So extraction will mean earlier if there were n processes, highest one will be removed and then you will be left with n minus 1 processes. On the other hand, find max means there are n processes, find the process with highest priority, but don't remove it. So find process activity will be taken place. So this is the way these two differ. Others we will go one by one. So I say find max is the first operation. Before that, now I have to think of having max heap to be implemented as the corresponding array, of course, but it will not be, or I'll say earlier I had max heap as a simple integer array, but if I simply write int pq, let's say 50, it's a priority queue of a 50 elements, only int might not be sufficient. Maybe I want to store a full process. So I will say I will have a process structure where I will, of course, have a process ID. Along with this, many other fields, whatever I need, plus I will have int the priority, or whether you say it as a key, because a key is also a common word used. Key is unique, and on basis of it, whatever processing we do, that is we call as a key. So if my priority queue is maintained based on certain particular field, that field we called as a key. And if you specifically want to use the word priority, still you get one and the same thing. So now I will declare the corresponding array as array of struct process. So my PQ will be nothing but an array of 50 processes. Of course, you are already aware that I can also do it as by writing type def struct process. Let me just take this. If you write it here, type def struct process and do everything, write here also word process. Then later, you can simply use the word process and declare PQ of 50. So I'm giving both situations to you. The word struct will be needed to be repeated every time if you have not used type def. If you have used type def and made the new structure name as a process, Now, once this becomes a new data type, later any variable can be declared of type this by using word process directly without a struct. Small difference, but you should know that. So now I say, I have got this. Let's go one by one for the operation find max. Find max. Of course, I should decide what parameters do I need and what return should I have. So in all cases, probably I can easily see the PQ itself needs to be passed. The size or total number of elements needed to be passed. And there may be something else needed could be decided. Find max. So it is going to return the maximum values element. In this case, because I am saying the elements are nothing but processes, so my process should be returned from this activity. So maybe I'll have PQ and with syntax. I'm not writing the syntax, but this is what we need to do. Well, it's a max heap. I'm saying n elements all are arranged automatically in the max heap through the internal operations wherever we done. So where will be the max available? Obviously at the first position. So I have nothing big to do except return PQ1. Not a big deal at all. Of course, I am saying that how n elements came, maybe one by one insertions were done, or initially whatever processes were available, they were implemented using build max heap kind of a thing. But now, whenever operations are started, the PQ is already as a max heap. So PQ at all times will be always a max heap. And now you have to just find max will mean simply get the first index. I assume elements are in the index 1 to n. Of course, you can do 0 to n minus 1 also. Then accordingly, the coding can change. Second, extract max. Very similar. And probably the data type and the parameters all will remain same because we have the similar operation. But effectively, this means the process with the highest priority needs to be removed. That means PQ1 effectively needs to be removed also. So if I have to remove that, I have to think of a logic. Removal from the root or from the index 1 will disturb the whole max heap. So I have to probably do something better. Yes, you know, in heap sort also, effectively we remove the first element by doing some adjustment in the heap sort algo. Yes, exactly same way what we will do here. Say if I have a PQ here, obviously this element has got highest priority, let's say 20 priority plus whatever details were there. All others are here, definitely with a lesser priority. And now I have to remove this element. From here, removal is always a challenging. So what we always did was we interchanged value with nth value, and then we effectively removed this element. Earlier we interchanged. Now I say no need to interchange. I will simply bring nth value to this place, and then I'm going to ultimately extract this. So first, because this element is to be returned, maybe I will have a temp process. Temp process is there. I'll just correct that. So temp process will be there, which will be storing PQ1. But here also I have to put a condition whether n satisfies condition or not. Say if n is greater than equal to 1 only, then this can be done. Similarly, let's say if n is 0, obviously it won't work. So if n is greater than 0, only then this element exists. Otherwise, I can definitely say whatever message. So while doing programming, you have to be careful. So I assume this is correct. Then I have got this. Why I'm storing? Ultimately, later, I'm going to write return statement. I'm going to write a return temp process. So this I need to just return temp process. And that's why I stored initially. Why I stored? PQ1 will be overwritten by the nth element. So what I will say, now effectively I have to do nothing but store the nth element onto this place. The same thing we have done in the heap sort also. The only change was there we swapped because first element was the highest. We wanted to keep it at the nth place. Now I don't need the highest priority job to be kept at nth place. So I will not swap. I will simply bring PQN at the first position. Remember, I am copying the whole full process, not just priority. Full process is being copied so that all details are copied, although max heap will be maintained based on priority only. Now what to do? PQ1 has been replaced where priority is definitely lesser than the initial priority, and that will disturb the max heap property for the root element. So obviously I have to adjust, and we already know that we have operation available as max heapify. So I can call max heapify, PQ to be called. Before that, n is to be reduced because n will become 1 less. So I will reduce n, and then I say total elements have been reduced. And here, which element is to be adjusted, node number to be adjusted for heapification, assuming that its children satisfy the heapify property, but current node is not. Obviously, that is node 1. And then I will adjust that. It will again become max heap. And of course, because the process was to be returned, it will be returned by this process. Simple enough. Max extract max, not a difficult one at all. Now comes some interesting operation, insert. So insert, of course, PQ, N. Do I need something more? And what should be the return type? I have to select. Something more definitely needed. The new process which I want to add. That has to be supplied. So it's a full process to be added. Again, how to insert. Now you already know insertion. Max heap has n elements. Of course, the nth. So correspondingly n based something, if I have to check, I will do that. And accordingly, whatever decision taken. But ultimately, the element will be added at the last only. Whatever array we have, insertion automatically means that we, in case of a max heap, we simply, what we will do is this up to this, the position is already full, let's say 1 to n. Whatever priority of the new process is, where to put, I have no idea. But if I put anywhere randomly, it will disturb the whole max heap, and it is not sorted, so I cannot guaranteedly find in theta and time where to put. So what is the solution? The solution is that this is a kind of CBT, complete binary tree, or max heap. Let's say it is fill up to this. I will say add the new element here. New process will be added here. So at n plus first position, effectively, I will add the new element. This will not disturb others, but once it has got its priority, let's say is 15, above could be priority, maybe let's say 10, maybe 20 also. But if it is a 10, the property might have been violated. So I'll say the priority is here 10, connections are like this. In that case, there will be some change needed. For the first time, I'm saying change will be now going upwards. Till now in Maxify, etc., everywhere, we were bringing a smaller element downwards. So what I will say, n equal to n plus 1. Of course, within the limit, if I have my upper limit of n, let's say 50 or whatever, said accordingly, I have to check that I am not crossing that limit. And then I will say PQN equal to new process. But this element might not be satisfying the PQ property, and its children are satisfying, but it might not be satisfying in the upward direction. So obviously, I have to now keep on comparing with its parents and accordingly do some adjustments. I repeat, let's say I have a process here with some priority 20. This could be something less than 20. This could be something less than 20. Say I have here also something, here also something, here also something, here also something. These also have, these also have. And now you got a new process added. Let's say this process ID has or priority is 30. Obviously, this priority is, let's say, 12 or something like this. 30, imagine instead of 30, if it was a 10, it was perfect. If it was, let's say, 16, it will require go up and stay here. But if it is a 30, 30 will mean go up, and up to this also. So that means effectively, I need this process to climb up towards the parents. So for the first time, I need to climb towards the parents also. And we have not earlier practiced similar logic. So what we will do, I will say, of course, I have to repeat. I will write some loop needed. Later we will see what loop. Ultimately, I say that there might be a situation that PQN will be swapped with PQ n by 2 because n by 2 is its parent. And once it is swapped, I don't stop. Like if it was a 30, this will come downwards. So this becomes a 12. 30 reaches here, but 30 further deserves to compare and with its parent and further back. So n will be further now changed to n by 2. You can take a separate variable also, I also, or you can even use n also. So I will prefer to have, let's say, a better programming. Why? I'll just explain. So I will say, I will have n is already increased to n plus 1. I said PQ was being passed. So in this PQ, n is increased. Then I said, now PQ of n is added with the new process. Why I am now just writing this code is I need to send n as a call by reference because n is changing. So that will actually mean that insert wherever you are sending a PQ, in PQ, it's an array, a new element will get added without difficulty, but simply n is sent will be called by value. So you have to probably send it as a by a pointer, star n, that will indirectly mean you have to use a star n everywhere. That will indirectly mean this. So later I will say, okay, let it become I equal to star n. And then I will say, I need a loop condition we will write. And ultimately I need is PQI to be swapped with PQ I by 2. So that's its parent. And next time, I to become I by 2. And I should keep on repeating. The question is how many times? Of course, when swapping doesn't happen, of course, I will not swap. I'll not require to continue because once already heap property is satisfied, no need to further climb up. Second, might be you have nothing more to go up. Yes, that will mean you reached to the corresponding root. So maybe I will say while let me write the condition now. Think in these terms that some condition will be needed to be written as say while I has a condition of something and my priority should be of the ith element EQI's priority or key, whatever field you used, let's say I said key, if it is greater than my parents key, I need to really swap. Which is the parent key? I can easily find by using I by 2 and dot key like this. So PQI by 2 dot key, and I approximately like this condition, and I will keep on doing like this. And either I will reach to the root, then also I can stop, or if this comparison leads that no change needed, current element is less priority or equal priority, so no swap needed, I can stop. Done. This is the third operation. Coming to the fourth operation. Last operation in so I say in this case I say increase key. So what should be the return type? We have to decide. Of course, a PQ will be passed, N will be passed, and do I need something more? Yes, I need something more. So I say some process key is to be in new key to be added. Which process? So I say some I told to me and some new K given to me. I means the corresponding index whose key is to be changed. So instead of I, let's use the word index itself so that things become more readable. Now, in real life, like in OS, index will not be supplied. So you have to find out the index. OS will not supply the index. Like I want to increase the priority of some process. Why do I want to increase? Like the process could be with a low priority and new processes keep on coming with higher priority. The low priority process will keep on waiting for long. If that keeps on waiting for long, obviously that will be not good. So OS internally ensures that low priority jobs process is increased priority with certain time. After some time, priority will be increased. So in OS or in priority scheduling, priority will never be decreased for anyone because priority is based on certain criteria. But if somebody is waiting for a long time, priority should be increased. So OS will not tell index because it doesn't know where is that process. So OS will send the process ID. Now, using process ID, you will find the index through some logic by searching. Where is that process stored? So that all process you will do while implementing, that you will find out the index. But now I assume index is known to me. So for my algorithmic programming, I say index is known to me. Then I don't bother how it will come. Of course, first of all, now, based on that, I have to ensure whether index is correct or not. So if index, say, greater than n, then is one situation. I have to do probably nothing. Secondly, maybe by mistake or by some call comes and priority is already greater than the current new priority being given. So this is a new priority being assigned. I will ensure that if my PQ with index dot key, if my PQ index dot key, if it is already greater than or equal to new key, of course, again, everything is perfect. I have nothing to change because priority cannot be decreased, and priority, even if it is already the same, then no change needed. So no change to be done. Otherwise, what to do? Now, what to do is, one simple way could be that I write PQ index dot Q, else I will say. So else this key can be assigned equal to the new key, but then adjustment is to be done. That is what is exactly needed, because only key change is not sufficient. Adjustment in which direction? That we have to see. Adjustment in which direction? The key has been increased. In maxify, etc., the node gets disturbed, where key gets decreased, and then we have to bring the decreased value downwards. Here the key has been increased, means the value has to be traversed upwards. So effectively, adjustment is similar to what we have done in the insert. So whatever we did in the insert, the same logic, more or less, the same adjustment is still needed. So either we can rewrite the whole code, or what we could simply say is that we will play smarter. What we will do is, I will say the correspondingly PQ index dot key I have already assigned with the new key, and then again I can apply the similar kind of a, say, taking I equal to index and then going for while loop, etc., etc., and then doing all those adjustments and like this. So more or less similar adjustment as we did with in the insertion. As done in insert. So this is a way to do what book or what Corman also even suggested. The smart way was applied on insertion, to do insertion now using the same insert. That insert key will be implemented the way we just did. So I said, oh, sorry, increase key will be done the way we just did by writing the full logic. So increase key function, whatever we have been writing till now, did this plus did this, done, over. And maybe I can have this as a void or return whatever you want. But then insert, I will say, in case of an insert, I need not write the whole code again. In insert function, whatever parameters you were doing, whatever you were doing, I say, what I will do is, I will insert the new process with minus infinity as initially, as initial priority. The advantage means that minus infinity as initial priority directly fits into the max heap at the last position without a difficulty. And then we will call increase key to bring the priority to actual value. So that just changes the way in a way that you need not rewrite the whole code, effectively meaning nothing but I will say new k is nothing but new process dot key. So I store new process dot key, and later I will say new process is assigned dot key is assigned minus infinity or min int or int min, whatever you say. And then I will say, effectively, I added n equal to n plus 1, pq n equal to the new process. And because new process has a minus infinity, it still fits perfectly in the peak. Then I call increase key. So PQ is passed. N is also the total size. The index is also N here, for which the key is to be increased. And what is to be given is new K as a priority. This new K will be assigned as an increase key to the index nth, and that will be equivalent to insert. Doesn't matter. Either you do this or you can directly write the corresponding loop directly, while loop and whole code, one and the same thing. So with this, effectively, main operations over priority queue are over. And just to give you an idea for your practice, maybe if you want to code of your own, then you can pause this video and don't see at the code. But if you want to see the solution, let me just have a temporary code shown to you. And those who are willing to try of their own, they may pause the video before seeing this solution. And those who are willing to see partial code for this, I'm going to show you partial code for the priority queue on the screen within a few seconds. Yeah, so it's there. So now let me again share the screen. And my meeting is continuing. Yeah, there is Zoom meeting. Yeah, so let me now share my screen again once. Yes, so here is the temporary code available. Like I said, I have the job or process along with job ID. There can be other fields also. So I can have other fields also here if needed. Then priority is already there. Struct job process ID max number of max elements I can declare so that I can check the upper limits, etc. every time. Then for implementation now, I want all of you to have a repetition that give option to user for doing all operations one by one till the exit is not pressed. Repeat. While choice equal to, maybe you can give an even choice equal to 5 to exit, 1 for insert, 2 for while choice not equal to 5 you could do. That also can be one way of doing. So you could say 5 for exit, and you could say 1 for insert, 2 for extract max, 3 for maximum, 4 for increase, or else display, 5 for display, maybe 6 for display of the whole max priority queue. And then you could say, I will have 6 for exit. And then here you can say, while choice is not equal to 6, you could repeat. So you can keep on asking the user, and based on the choice given by the user, you should call one by one. And accordingly, based on the choice, you should have here the code to have switch else statement and call the corresponding operation. Well, Extract max and find max are similar. So I'm just showing you code for extract max. Job is to be returned based on condition. Otherwise, you will find out the priority Q1 and then adjust it and max CP5. We have just said. Increase key, as I said, that the priority queue will be passed, new priority will be given, new ID, or I'll say for implementation from process viewpoint, I will be supplying the process ID only. So process ID is given to you. Using that ID, find out the index. If index is say returned as beyond limit, you can accordingly return and then say ID is not found, element doesn't exist. Otherwise, you will compare and find whether new priority is greater than the current one or not. If not, nothing to be done. Else, you added that, changed that priority, and along with that, you repeat the loop, swap with the parent, and then change the index. Keep on repeating as long as swapping is needed. Then insertion can become simple. That insertion will mean nothing big, that we have the corresponding parameters plus the new job to be added. So correspondingly, you have to append the job with say min int or say int min. Now, because some of you must be aware with int min priority at the end of this, and then you can call increase key directly by using this. And then later, if you require, you can display. Max CP5 you will require, so you can call that. If initially you want to take n elements collectively and then arrange them, then you can call build mix, build heap also. Otherwise, you can assume priority queue to be initially empty, keep on inserting values, automatically everything will happen, build heap will not be needed. I think with this, I will stop and stop the recording also. Try to do all this implementation and hopefully you will get a better feel of the max heap and priority queue also. All the best. Bye-bye.